Welcome to the Weather and Climate Target Quiz number 2 review. In this video review, we're going to be talking about what causes the Earth to be unevenly heated, considering as that it all receives sunlight from the same sun. So to start off, let's look at our discussion on the fact that the tilt of the Earth's axis is the cause of different seasons. Over here on the left side, we can see that when the northern hemisphere is angled toward the sun, so the top part of the axis, which again is that imaginary line sticking through the Earth around which the Earth spins. So since that is pointed towards the sun, the northern hemisphere is receiving more direct sunlight while the southern hemisphere is receiving less direct sunlight. So this up top would be receiving summer sun, and down below they're going to be in winter. If we go all the way around to the opposite side of the sun, now you can see that the northern hemisphere, the axis is angled away from the sun. So we are now in the northern hemisphere receiving less direct sunlight. In the southern hemisphere, they are receiving the most direct sunlight, which then translates into more heat. And at this point, in the winter area in the north and the summer area in the south. So that's one way. The tilt of the Earth's axis. Then I went into a long, drawn-out discussion about the fact that color also has the ability to alter the amount of heat that is being absorbed by the Earth. I talked about the fact that sunlight is made up of white light, which is all the different colors of light combined together. There's this lovely picture at the bottom that shows how you can use a prism right here. And when the white light hits the prism, it refracts because it's hitting a new medium at an angle, and the different wavelengths of light all bend at a different amount, which is what spreads those lights out over here along that platform. So that's just a background of white light. We then talked about the electromagnetic spectrum. A couple points here. Over on the far left over here, this is going to be a decrease in frequency and a wavelength increase. So it's got bigger wavelengths, but the frequency is less. And over on the right side, it's going to have an increase in frequency and the wavelength is going to decrease. So they're kind of opposites there. On the left side, this is associated with a lower level of energy, and on the right side, it's associated with a higher level of energy. Well, the same goes for this little chunk of visible light here that they've expanded. The red light is on the left side, so it's going to have less energy. The blue and purple and violet light on the right side is going to have more energy, which then takes us to the next slide where we had these lovely pictures talking about why we see different colors. Oops, let's go back to that one. So again, all of these pictures show that white light is hitting it from the left. When it hits whatever material is down there, some of the light is absorbed and some of the light is reflected back. So the red patch, only red light is being reflected back. Green light, green is reflecting back that green color. The important stuff over here though is white. When the white light hits that white patch, all of that light comes back. So it's reflecting most of that energy away from it, which means that it's not going to absorb much energy and it's going to take longer for that to heat up. And if you look at this black patch, when that white light hits it, it absorbs all of it. Now, a lot of you are saying it sucks up energy. I don't want to use that term. I would rather use the term it's absorbing energy from the sun and converting that energy into heat. Whereas the white is not, this is actually reflecting that energy off, so it's taking longer for it to absorb the energy to create heat. And finally, on the next slide, we know that because dark objects are absorbing more of the colors, they're absorbing that energy and then converting it to heat. And lighter colors are then reflecting more of that energy back out into space, so it's taking longer for that to heat up. So we just talked about the fact that different surfaces of the Earth are different color. You've got snow, ice, those are reflecting more light. They're really light colored. We have rocks and dirt that are really dark. I also talked a lot about asphalt parking lots and the roofs on houses, and you guys really glommed onto that because I think all of you have experience with that. But it's the same with any other surface on the Earth. If it's dark, it's going to absorb energy and it's going to convert it to heat. If it's light, it's going to reflect energy off of it and it's going to take longer to heat. We then talked about something else a little bit different in the book, and that was the Earth's atmosphere. We said that clouds, when the sunlight comes into our atmosphere, some of it's going to be bounced right back out into space because of clouds. So if it's really cloudy over a certain area, it's not going to get as much sunlight. Particles in the atmosphere, we've got water vapor, carbon dioxide, dust, and different chemicals that are floating around, different gases that are floating around, are going to absorb some of that energy, and it's not necessarily going to make it to the Earth. And interesting point, only about 50% of the sun's energy actually makes it to the Earth. So if you're looking at this energy coming towards the Earth, about half of it is either absorbed in the atmosphere or bounced back out into space. So only part of what actually comes to Earth makes it to the Earth's surface. So to summarize, Earth's axis, the tilt on its axis, because it's tilted, wherever it is around the sun, part of the Earth is getting more direct sunlight. It's not that they're getting more sunlight necessarily, it's just that it's more direct. And the other part of the Earth, that sunlight is being spread out over a larger area, so the energy is also being spread out over a large area. So if you're getting the direct sunlight, that's summer. If you're getting the indirect sunlight, that's winter. Another reason is colors. Darker colors absorb more energy. So rocks and dirt and other dark colored things, parking lots, houses, are going to be absorbing that heat, or the energy, and converting it to heat. Lighter color things are going to be reflecting it off and not absorbing as much energy, so it takes longer to heat. And finally, clouds and particles in the atmosphere can also absorb some of the Earth's energy, which again could make it take longer for parts of the Earth to get warm because they're not receiving as much of that energy. Hope this has helped you. Please check in for more videos, and good luck on that science.